In this section, we are going to learn the basics of C++ and the data structures which we will be using in our upcoming sessions. So let's begin. So what is a container? So container is basically a storage space for your elements. It provides member functions to access them either directly or through iterators. Iterators are reference objects with similar properties like pointers. Containers replicate structures very commonly used in programming, such as dynamic arrays, also called vectors, queues, stacks, heaps, priority queues, linked list, trees, set, associative arrays, such as maps. What is a take queue? So take queue is a double-ended queue. Using a take queue, you can take inputs from both the side. So basically, it works both ways. So using the queue, you can expand or contract on both ends, either its front or its back. Maps are associative containers that store elements formed by a combination of a key value and a mapped value. In a map, the key values are generally used to sort and uniquely identify the elements, while the mapped values store the content associated to that key. The type of key and mapped value may differ and are grouped together in member type, value type, which is a pair type combining both. Stacks, before stack. So basically, stacks follow last in, first out. So if you are inserting an element, then it will extract only from one end of the container. Queues are a type of container adapter specifically designed to operate in FIFO context. So unlike stacks, they work using FIFO, which is first in and first out. So elements are inserted into one end of the container and extracted from the other. Queues can be encapsulated using a specific container class such as its underlying container, providing a specific set of member functions to access its elements. Elements are pushed into back of the specific container and popped from its front. So a heap is a way to organize the elements of a range that allows for faster retrieval of the element with the highest value at any moment. The element with the highest value is always pointed by first. The order of other elements depends on the particular implementation of the heap. Basically, this is a simple template to initialize a heap in your programs. Vectors are sequences containing representing arrays that can change in size. So vectors are basically dynamic arrays, and they use contiguous storage location for the elements, which means that the elements can also be accessed using offsets on regular pointers to its element and just as efficiently as in arrays. To initialize a vector, you can initialize it using class T, class allocation, and class vector. So C++ has enumeration type that are directly inherited from C and work similarly. So the C++enum keyword is automatically combined with a type definition, so that instead of naming the type enumeration name, simply name it name. This can be simulated in C using a type definition, and enum name and values. So binary trees. Binary trees means that node can have maximum 2 children, as you can see. So there are various kind of binary trees. So full binary tree, complete binary tree, perfect binary tree, degenerate binary tree, and balanced binary tree. Full binary tree are also known as strict binary tree. So each node must contain either 0 or 2 children. In complete binary tree, all nodes are completely filled and all the nodes in the last label are added as the left first. Perfect binary tree has all the internal nodes of 2 children, and a degenerate binary tree has 1 children only. Then balanced binary tree is a tree in which both the left and right tree differ by at most 1. In our later upcoming sessions, we will learn how to implement a binary tree. Till then, take care and bye. Hi guys, in this session we will be writing a stack using Cplusplus. So without any delay, let's get it started. Let's define our main function. So in this empty stack one, we are pushing our elements currently. Q works, we can do a similar program with Q. So we need to call Q and then we can create an empty queue and then we can push the values successively, and just to check out our program if it's working. Then here we are, our queue size consists of 3 elements. I will see you in the next session in which we will learn some more useful data structures and algorithm. Till then, bye and take care. Now you need to assign the value as per the type. Okay. So then you initialize a day queue. Like suppose we want to create a day queue which is having some values, then we just we can enter it here. So here we are assigning some values to the day queue. Or we can do one thing, we can try to push it. Okay, so here we have initialized our day queue, as you can see. And let's hope it works. Okay, so we are getting an error, extended initializer list only available with. So, okay. So you can use this initializer with C++11 or GNU++11. So that is the issue we're facing. So let's remove this line and look at some of the DQ functions that we can use. Here we can do DQ1 pop front. So what this will do, this will remove the element from the front Let's see how it works. Okay, so let's print out the element of the queue. So let's run this. Yep. So here is our DQ. So currently we are assigning 422 values, and we are removing one of the values. So the queue has 421 values in total, and then we are getting our the queue. So since we are removing our front value, we are only getting the last value of 432 printed 421 times. So you can do a lot of exciting things with the queues, especially if you are working with queues. I will see you in the next session. Till then, bye and take. This session we will be looking into polymorphism. So polymorphism is using class inheritance so that a pointer to a derived class is type compatible with the pointer to its base class. So here we are looking at the rectangle and triangle classes that can be written using pointers by taking this feature into account. So first of all, we define a class polygon, then we define variables inside protected and public type. Moving further, we go to class rectangle. In class rectangle, we define the properties using our public polygon class. So we are using the inheritance here. Again, we are moving to triangle and we are using the public polygon class. Now we can use the pointers to calculate various values related to our polygons like rectangle area, triangle area, and so on. So let's run this program. So here we have rectangle area and triangle area. So just like that, you can use polymorphism to use a previous declared class by comparing their base value type. So I will see you in the next session. Till then, bye. And so what are abstract classes? So abstract classes are very much similar to the previous program we saw using the polygon. So in abstract classes, we can use pointers and take advantage of polymorphic abilities so that the pointer declarations can be valid. So as you can see here, in class polygon, we are defining the protected and public values. So this void zero actually what it does. Suppose if a area has no definition, then you can assign it a value of zero, which makes it a pure virtual function. So that is quite important how to use pure virtual functions if you are doing polymorphism using abstract classes. So let's test it out. Okay. Hi guys, in this session we will be creating a binary tree. So as you know, there are various forms of binary tree. It can be a full binary tree, which is a special type of binary tree in which every parent has either two or no children. A perfect binary tree which has two child, and a complete binary tree where every label must be completely filled. Then we also have degenerate or pathological tree. So in this tree, they have a single child either left or right. Then a skewed binary tree where left and right side are skewed, like one of the side is more dominated than balanced binary tree. So how binary tree are represented? So first you create a node structure, then you define the data, then you create the node left and right. So let's get started. So we will include this header, then we will move to namespace, then we will start doing our node. So now we will write about our node. Now we will be creating our new node. So let's start with start node. node, struct, node, now we will transverse the pre-order. After writing this, we will be writing our main function in our next session. So first we created a node, then we wrote function for pre-order, in-order, and post-order by assigning the variable left, right to various node functions. So basically this is containing a data part and two pointer left and right which have null value. I will be meeting you in next session in which we will be defining our main function and then we will be running our code. Thanks. We will be defining our main function. So let's get started. So call the structure node by point to root, then new node 1, then root is equal to left, new node 2, then root is equal to right, new node 3, then root equal to left is equal to right, left is equal to new node 4. Now let's get our node output. Okay guys, so we are ready to test our program. So let's test the syntaxes first. So here we are missing a O and in order transversal, then root, gate, yeah. So we are still seeing some error saying it's undefined. Okay. So we have the transversal, and then we call first P of the root. So is there spelling mistake? Yes. We need to fix this and fix here also. And now we are ready to go. So without any delay, let's run it. So here we have output for pre-order transversal, in-order transversal, and post-order transversal. So you can do a lot of interesting things using binary tree structures. I will see you in the next session. Till then, bye and take care. Hi guys, in this session we'll be making a heap using range. So let's begin. So first of all, we need to include algorithm and vectors in our header. So let's begin. Then we include the algorithm. Then we include the vector. Now we define our main function. So here we are in my int. Let's initialize it using a list. Okay, we have initialized it. Now Now initialize our vector. Here we are missing the columns. Okay, my int. So we initialize it. So basically, we are giving it a range of first element to the last element here. Now let's make the heap. Okay, now we will be giving our iterators. So it can be v begin to bn. Now we need to see out this. Let's do that. So this refund will give us the max heap from the front. Then suppose if we are popping one element, so we can write for that as well. So let's call it pop heap. Now let's see out this. Now let's to use the pushback function. So let's push the element also here. Let's see if it works or not. Let's try to initialize it again. So okay, let's use push heap here. std push heap, or just let's call it push back. Then do the push heap. Here need to give a range. So max heap after push. Now let's do the sort. From where to where. So here we have to give the value to be, uh, now let's print the final sorted range. For smaller than v size, then iterate here, and let's see out pi. Here we are. So we can get the max heap size, which is 30, that we can see here. And once we remove the front the front contains the maximum value element, that is 30. So once we remove 30, it will be changed to 20, which we are doing here when we are popping it. Then we push one more element, 99. So if you push 99, then max heap after push becomes 99. So the final sorted range will be 5, 10, 15, and 20 and 99. So you can use heaps with range. In this session, we'll be looking into some of the common sorting algorithms such as bead sort. So bead sort is also called gravity sort, which is a natural sorting algorithm. So first of all, you need to use stream vector as the header, and then you need to initialize the vector, the data type. Here we are using a list to sort the bead sort. Then we are defining the conditions, and then we are calling our bead sort, and using the pointer we are assigning the values. So now we are sorting our data by beads falling down, beads on their sides, beads right side up, and we are returning the values. Just like that, we have next sorting algorithm called heap sort. To use heap sort, you need to call algorithm, iterator, and iostream. Then here we are initializing a template with type name random access iterator. Then in the heap sort, we are assigning the begin and the end values, and we are just adding the function make heap and sort heap, and then we assign the data types. Then we see out the original values and we see out the sorted values. So next one is selection sort. So basically selection sort algorithm sorts an array by finding the minimum element in ascending order. So just like the previous one, we will be using the same code format, and then we will be calling our selection sort here. Then for iterator begin, for iterator end, then using the loop, and then inside our main function we will assign the data values, then we will print out the previous data, and the data is sorted using the selection sort. So let's see how this works inside our ID in our next session. Till then, bye and take care. So we are feeding the values starting from 125 to 55. Then we are sorting it based on the ascending order, as you can see here, using the selection sort. So you can use these sorting algorithms if you are working with large data types and you want them in ascending order. I will see you in the next session, in which we will be looking into some more common algorithms used in day-to-day programming. Thank you. In this session, we will be discussing about a stable sort. So basically we do a stable sort if we want to maintain the relative order of records with equal values. So like suppose we have two data values and one data values appear before the next data value. So we want to maintain this strictly. So for that we can use a stable sort. So whenever that data is displayed, the data which we want first will be displayed first. Suppose we start with double value where int j is greater than int I, then we assign the values, then we initialize the vector and we assign the values to the vector. Then when we do default comparison, we can do C or C out, and then we can simply run a stable sort from beginning to the end, and we can see the outputs using for loop to iterate through all the elements. Just like that partial sort. So basically partial sort is used if you want to display from beginning to end and you are having more emphasis on the middle element. So basically how it works. So it returns you a list of items such that its element all appear in order, while partial sorting is returning a list of the key smallest elements in order. Okay, so we can do a quick check how this looks. Suppose we have values from 91, 82, 72. Okay, so we are giving this data and we are trying to partially sort it. So we will get the minimum value first. So basically it gives you data in ascending order starting from the very minimum value which may be inside the uh, which may be inside your array. So let's move to our next section in which we will be looking into some of the search algorithms. So first of all, we will be looking into binary search. So what does binary search does and why we use it in algorithms. So basically binary search is a searching algorithm to suppose you are given an array of an element and you want to write a function to search a given element if it is present inside or not. Then you can use binary search. Basically, it's much like the deque operations we did. So we will sort from beginning to end after initializing the values in a vector. Then we can do a default comparison like from if from beginning to end binary search result returns this value. So the value that we are searching will be put into this bracket, and then just like that if you're looking for another value we can just follow the same logic here. Suppose we are looking for 9, then we will be using 9 here, and yeah. Basically, it's very simple algorithm and one of the most basic search algorithm. If you are trying to write a function to locate the element in various array values, then we have lower bound search. So how this works? So basically, lower bound search helps you find the minimum array minimum array element in a given array. So suppose you are using an iterator pointing to the first element in the range, which has the value not less than value. This means that the function returns an iterator pointing to the next smallest number that will be bigger than or equal to that number. So basically, if you use lower bound search, it will be giving you a number that will be less than or just a little bit bigger than the number. So we will look this in our next section, how this code works. Then we have upper bound search. So just the opposite of lower bound. What upper bound does is that if you are looking for an element using upper bound, then it will give you a subset value like an element that is greater than or equal to all the elements in a given set. So if you want to find a number that is greater than the medium value of the like the average value of the set, then you can use upper bound. So minimum element and max element. So this you can use if you want to find the minimum element or maximum element of the array. So basically, you initialize the value, like you can put a function structure. Then you need to start the comparison. The comparison process is quite simple, just like the one we did previous. So basically, we put the variables and what we are comparing it with. So we will look more into this in our upcoming sessions, and we will also look into some advanced algorithms. Till see you and bye. Session will be looking into algorithms and NTL. So first of all, one is lexicographical compare, which is a type of algorithm we use to sort the alphabets in order. So the process of using it remains the same as the algorithms we used before. We need to declare it, and then using the iterators, we can implement it. In NTL, we can use very fast polynomial arithmetic processing. Basically, NTL was developed for computer algebra. So it has various dedicated classes, such as ZZX represents univariate polynomials with integer coefficients. Um, here is a simple program using NTL that does factorization. So first of all, we declare it and then we do the factorization. NTL has also support for modular integer arithmetic. The class ZZP represents the vector. The mat ZZP represents matrices and ZZPS represents polynomials. Here P doesn't need to be a prime. For example, we will see a program that reads a prime number P and polynomial f modulo P and factors it. So here we are entering a polynomial and then we are entering another polynomial and then we are doing the factorization. Arbitrary precision floating points. NTL also supports arbitrary precision floating points with the class RR. So in this program, we are reading a list of numbers from the input and output sum of their squares using the class RR. So we are declaring the values, then we are printing of the square. Greedy algorithms. So greedy algorithms are used to optimize program in a best possible way. Dijkstra algorithm is called a single source shortest path algorithm. It is based on predict technique. The algorithm maintains a list which state of vertices whose shortest distance from the source is already known. In our upcoming session, we will look into similar programs that use this algorithm. Till then, bye and take care. This session, we'll be looking into one of the programs that uses the extra algorithm. So, we are using a wrapper class for storing a graph. When we are declaring a graph, so in our graph, we are constructing a graph with V vertices and E edges. We are initializing it using the array edges. Then we are filling the array with zeros. So after that, we are adding the edge to the graph. Then we are giving a utility function to find the minimum distance, vertex and next. Then we are giving a utility function to print the distances. Now we are giving the main function using extra that finds the shortest path from the given source. To all other vertices using extra algorithm, it doesn't work on negative. Then we are starting our function, initializing the graph. Then storing the updated distances to the vertex, initializing m distance and b set. Then we iterate it to find the shortest path. Then we call our main function, see in the number of vertices and edges, and see in the source, destination, and weight for the graph type. Then we make sure that source and destination are in proper bounds. Then we calculate the distances. So let's see how it looks when we implement it. So it will ask us for number of vertices. Let's say it's 6, or let's call it 7. Number of edges, let's call it 4. Then source, destination, weight, source, destination, weight, source, destination, weight. So since it is 23, so it is out of bound. Source, destination, weight, source, destination, weight. So now we have the vertex and the distances for all the 7 vertices and 4 edges. So you can use this algorithm if you are working on tree structures where you have to optimize your nodes. I will see you in the next session. Till then, bye and take care.